Hi everyone, this is Mr. Celona. I'll be working today with Mr. Hermann on demonstrating for you the Newton's second law lab. So let's talk about what that lab is all about. So the purpose of this lab is to investigate the effects of system mass on the acceleration of a system and the effects of applied force on the acceleration of a system also. So essentially what we're doing is we want to see how does changing the mass of an object or changing the mass of a system affect how much it accelerates, and then also look at how is it affected by force. So if we apply more force or less force, how does that affect the acceleration as well? We're going to do this in two parts. So part one of the lab will feature a constant force being applied to the lab cart. So we're always going to pull with the same amount of force, but we're going to change the lab cart's mass. Actually, we're going to change the amount of load in the cart to change the mass of the system. And then in part two, we'll keep the mass of the system constant, but we're going to apply different amounts of force to the cart. And we'll do that by hanging different amounts of weight from a string attached to a pulley. In both parts, the acceleration of the system is going to be measured using a smart pulley device, which you'll see when we show you the lab setup. So we're going to transition over to the lab setup where we're going to explain how the equipment is set up and how it works, and then go through data collection with you.
So this lab's going to happen in two parts. The first part of the lab, we're going to take a mass and place it down here on the hook, and this cart's going to accelerate towards the end of the track. Now, what's causing that acceleration is going to be the force of gravity applied to this mass. Gravity's not accelerating this directly, but rather creating a force on this mass, which is then going to use tension through the string to pull the cart. Now, you want to be able to determine the force of gravity on this mass. So this is a 50-gram mass. First thing you want to do is convert that to kilograms. So it's going to be 0.05 kilograms. With that, you want to multiply the 0.05 kilograms by the acceleration due to gravity, 9.8 meters per second squared. That will give you the force of gravity responsible for accelerating the entire system.
So you can put that, I'm sorry to cut you off. So put that in our table here. You can put in 0.05 kilograms times 9.8 gives us a force applied of 0.49 newtons. So you can see I added that to the table.
So the 0.49 newtons of applied force due to the force of gravity is going to be constant through the first trial. So we're going to let this go. It's going to accelerate towards the end of the track, and we're going to measure the acceleration. Then, keeping this mass where it is, we're going to take off the, so far we have a 500 grams placed onto the cart, and the cart itself is 250 grams. So that's a total of 750 grams here, plus another 50 grams here. So that's 800 grams of mass for the entire system for the first part. Then we're going to take off these two weights here, the two masses, and put on, I believe it was 400. So now we have 400 grams plus the 250 plus the 50. So that's 3, 4, 5, that's 700 grams of mass total for the first part of the lab, the second trial. Then we're going to go down to, I think it's 200? 250. Okay, I'll just put this one on there. So 250 for the cart, plus 250 on this weight, plus another 50 hanging, so the total mass of the system is going to be 550 grams. Then, for the next trial, we're taking this off. What are we putting on?
100 grams.
100 grams. So we'll have a 100 gram mass, plus the 250 of the cart, plus the 50 for the hanging mass, for a total of, what did we say, 400?
400, yep.
And is there a trial after that?
No, that's it.
Okay, so that's, go ahead.
You can see that I added those numbers into the table there. So the mass of the cart each time, the total mass of the system, and the force applied I only put in once because all the trials in part one are going to have the exact same force pulling the system. So you can just copy the same number down through trials 2 through 4 in part one.
Now, for the second part of the lab, we're going to keep the mass of the entire system the same, and we're going to swap out the masses that are sitting here with the mass on the hook, so we have a varying force applied, but a constant mass of the entire system. So we'll start with, I believe it was the
20 grams.
20 grams. So 20 grams hanging on the hook. Remember, you want to find the force of gravity that's causing the acceleration here. The force of gravity is going to be this mass in kilograms, 0.02 kilograms, times 9.8, the acceleration due to gravity, units of meters per second squared. So we have 20 grams here, plus 50, plus 100, plus 200, plus 250 for the mass of the cart. What does that give us for our total?
620 grams.
So 620 grams is the mass of the entire system. That's going to remain constant through the entire second part of this lab. But what will change with the second trial, in part 2 of the lab, we're going to replace our 20 gram mass with our 50 gram mass. So now there's a new applied force, but the total mass of the system is the same. Once again, we're going to let it go. We're going to measure the acceleration. And so for part 2, trial 2, the mass of the system is the same, but we've changed the applied force. Trial 3, we're going to replace the 50 gram mass and put the 100 gram mass against our applied force. So that's going to be 0.1 kilograms times 9.8. That'll be the applied force due to gravity. Mass of the system is still
620 grams.
620 grams. And then for the final trial, we'll then hang the 200 gram mass on the hook. Now there's a more substantial force of gravity accelerating the system, but the mass of the system once again is the same. And we're going to look at the effect that varying the force of gravity, the applied force, has on the acceleration of the cart.
So in each of the trials, you'll see us run the trial, and I will take the slope of the line of velocity versus time to get the acceleration. So you'll see that in the video. You can also go ahead and calculate the force applied in each trial of part 2. Mr. Hermann talked about how much mass was on the string multiplied by 9.8 meters per second squared. Remember that you have to be in kilograms. So if you have, for example, 20 grams, you're going to convert that to kilograms, get 0.02, and then multiply by 9.8. So you'll see I did the first trial here. I entered that in the table, but you can go ahead and calculate the remaining ones and enter them in for trials 2, 3, and 4. I also want to note that you see the theoretical acceleration and the percent error in this data table. We're going to do that part after the experiment is all over, because we're going to look at what does Newton's second law tell us our results should be versus what actual results we got when we did the measurements, and look at the differences between those. Okay, hi everyone, this is Mr. Celona here with Mr. Hermann. We are here to run the Newton's second law lab. So in part 1, we're going to be running with the same amount of force in every trial on the cart, and we're going to change the mass in the cart and see how it affects the acceleration of the cart as it rolls across the track.
So in the cart we have 500 grams of mass, and the constant mass that's going to be hanging from this hook is 50 grams. This is going to be providing a constant force for acceleration for the cart, and we're going to change the mass on the cart.
All right, I'll say go, and then you can release the cart. Ready? Go. All right, so you can see that on the velocity versus time graph, we got this linear shape because the cart was accelerating across the table. I'm going to scale the graph, and then I'm going to take its slope so that I can find the acceleration of the cart as it went across. So let's get that slope. And for trial number 1, we got 0.5176 meters per second squared.
All right.
Okay, let's go on to trial 2.
How much we added?
So we're going to do 400 in the cart and keep the force the same.
400 in the cart?
Yep.
So,
Just take these two.
yeah. Make sure they don't shift. Okay.
All right, ready, set, go. Okay. On this one, our slope. So our acceleration is 0.6114 meters per second squared. Now we're going to do 250 grams in the cart. This is trial number 3, 250 grams. Ready, set, go. Okay. For this one, scale the graph and take the slope. Got 0.7868 meters per second squared. And for our last trial, we're going to do 100 grams in the cart. Ready, set, go. Okay, and then for this one, our slope is 1.103 meters per second squared. And those are all the trials for part 1. Okay, we're back for part 2. So in part 2, we're going to keep the mass of the system consistent, and we're going to change the amount of force pulling the cart. Mr. Hermann will explain to you how we're going to do that.
So we have a 20, a 50, a 100, and a 200 gram mass. We're going to begin with the 20 gram mass, providing the force to accelerate the cart. We're going to keep the other masses on here. For the next trial, we're going to swap masses, and we'll explain that as we go.
Okay, here we go. Trial number 1, 20 grams of mass on the string. Ready, set, go. Okay, so for this trial, our acceleration is 0.2556 meters per second squared.
All right, now I'm going to place the 50 gram mass as our force to cause the acceleration, and I've placed the 20 gram mass onto the cart, keeping the mass of the system the same.
Here we go. Ready, go. Okay. In this trial, we got 0.6963 meters per second squared.
All right. So now the 50 gram mass is back onto the cart. I'm going to take the 100 gram mass, bring that over. That's going to be our counterweight. This is the force creating the acceleration on the cart, but the mass of the system has stayed the same.
Here we go. Ready, and go. Re-highlight that a little bit. Okay, for this one we got 1.436 meters per second squared.
And now for the final trial, we're putting the 500 gram mass, the 200 gram mass on the hook. The rest of the masses are back here on the cart.
Okay, ready, set, go. You can see it fly across the table there. Alright, let's auto scale. Highlight. And our slope, our acceleration, 2.959 meters per second squared. So that's all our trials for part 2, where we'll be keeping the mass of the system constant.